Today we're gonna learn 2.5 equations of lines and space. I think this is the correct one. Yeah, okay. Last time we did that vector, right? So vector, so this is a vector V. Then we can express this one is 1 times of a vector V, right? 1. Okay, now I measure the vector V approximately and then make a double size. That's 2 times of a vector V, right? I believe this is 2 times of a vector V. Then we have a vector V and then I make a shrink half. That's 1/2 of a vector V, right? We did that. I think this is half. Okay, so take a look. We call this is parallel vectors. So in that case, they goes the same direction, right? So same direction. Okay, then we can express this one as vector W equal to K, which is a scalar of vector V, right? So we had a K equal to 1 times of vector V, 1 over vector V, K equal to 2 of vector V, and K equal to 1/2, then 1/2 of vector V, right? All right, then we can say that vector W and V are parallel for some scalar K, right? All right, then we can express this one. We can express this notation like this. So vector then come from 2 points, right? So PQ equal to, now K will be T, and then we are using same vector V notation. Okay, then PQ, P is the one, what is called the triple, no, order pair, order triple, right? And then Q is another triple, right? So let P equal to X naught, Y naught, Z naught. So this will read X of 0, subscription, right? We did that earlier, X of 0, or we read X naught. I think spell is correct, X naught. All right, so X naught, Y naught, Z naught, Q equal to, we can say the X of 1, Y of 1, Z of 1, or X, Y, Z simply. Okay, then the vector, right? This vector we can express X minus X naught for the first component, and Y minus Y sub 0, and Z minus Z sub 0, right? That's the left side. And T, just a scalar, we are using that. And vector V, we can express the vector V as ABC. Then we can distribute right side. Then that will be TA, TB, TC. All right, then we have a vector equation of a line. Vector equation of a line. So this is a vector R equal to R sub 0 plus T vector V. Yeah. This is the equation where R, always R reminds me. What kind of sounds is that? I can make a really good dog sound. X, Y, Z, R sub 0, which is X naught, Y naught, Z naught. Okay, now this is a vector equation, right? Parametric equation. So we have a parametric equation of a line. So x equal to x naught plus at, y equal to y naught plus bt, and z equal to z sub 0 plus ct, and abc numbers. Yeah, they don't mention that there's a scalar. Yeah, they just say numbers, right? And then in the vector, they're using scalar, right? The terminology. And the x naught, z naught, y naught come from x, y, z. Okay? All right, so parametric equation, we cover in Calculus 2. So if you don't remember, please watch last semester. So I made a YouTube video, so I'm gonna upload it here too in the Canvas. Yeah, so you might watch that. Or parametric equation. In the OpenStax, we have in Calculus 3 textbook, there is a 1.1 parametric equation. All right. Okay, now symmetric equation. Symmetric equation of a line. So this one is easier because we have a parametric equation that we solve for t, but we don't write down t. Let me show you. Solve for t from parametric equation. Let me denote the equation like that, okay? All right, so the parametric equation from the previously we have like this. Okay, paste, yeah. Okay, then let's start for t respectively, everything, yeah? So start for t. So the first one, t equal to, move this one other side and divide by 8, right? So there will be x minus x naught over a. And second one, same processing, t equal to y minus y naught over b. Yeah. Third one, z minus z naught over c, right? Okay, so altogether, because everything is t equal to t equal to t equal to that, right? Then t equal to this, they are all same, right? So t equal to x naught minus x minus x naught over a equal to y minus y naught over b equal to z minus z naught over c, right? Well, normally we don't put the t, so the symmetric equation will be x minus x naught over a, y minus y naught over b, z minus z naught over c. Yeah. Ooh. Okay, let's do example. Okay, so we have this example. Find parametric and symmetric equation of the line passing through points 1, 4, -2, -3, 5, 0. Okay, so parametric equation, let me bring here. This is, oh, yeah. So this is a parametric equation, right? Copy that. Okay, in order to find parametric equation, so we have to know ABC, yeah, and then we have the x naught, y naught, z naught, right? So there will be x naught, y naught, z naught, yeah. Okay, so how do you find the vector component ABC, right? So let's find out vector v equal to from the point PQ, right? So initial terminal, right? So initial point, terminal point, right? So vector component to form. So we have -3, -1, 5, -4, 0, -2, right? Okay, then we get -4, 1, 2. So that will be A, B, C. Yeah. Okay. Then we have X naught, Y naught, Z naught here. Copy. So go. So X equal to 1 plus -4, right? -4t. And Y equal to Y naught, which is a 4 plus 1t, right? So just the t then. And z equal to z naught, which is -2 plus ct, right? So this is parametric equation. Okay, now we want to solve for symmetric equation. So for symmetric equation, So we need to solve for t, right? All right, the first one, we had x, move this one, ooh. T is here, right? So move this one there and divide by -4 to solve for t. So we have a t equal to x minus 1/4. Second one, t equal to y minus 4. And the last one, t equal to z plus 2/2. Okay, then we can simplify this one, right? So that will be z/2 plus 1, right? Okay, that is a symmetric equation. So let me arrange. So we have symmetric equation. Let me denote it this way. And x minus 1/4, y minus 4, and z/2 plus 1. Is it good? Okay, let's take a look at this one. We have a point, call it M. We have a line, L. And then we connect point from P to M. Okay, then that will be perpendicular. All right. Okay, then we know the area of a parallelogram. If we draw like this, yeah, then area of a parallelogram we had last time. So magnitude of, in that case, PM cross product with, so let me use it here, PM and then vector V, yeah? So there will be PM cross product with vector V, right? Okay, then area of parallelogram, we had magnitude of vector PQ cross product of vector V, right? We can express this one is base times height, right? So in that case, magnitude of vector V with D. So this is the base. This is the height. Okay, now we want to know about the distance from the point M to the line L, right? So that is D. We can see that. So sorry for the that will be magnitude of PM cross product of vector V over magnitude of vector V. Can you see that? Okay, then we have a formula, distance from a point to a line. So let me bring up. Okay, so you could not see earlier. So here we go. Theorem 2.12, distance from a point to a line. So that point is not in the line, right? So think the point is not on the line. Yeah, the M in the case. All right, then the distance formula gives us magnitude of Pm cross product of vector V equal divided by the magnitude of vector V. All right. Okay, let's do this example. So find the distance between point M. M is here, and the line is here, right? So M is not in the line, on the line. So what is the distance? So we want to find out the distance. Yeah. Okay, so we have a symmetric equation. This is a symmetric equation. Then let's find out parametric equation. Why? Because we want to know about the vector. Yeah, so we need to find out vector PM. So P from the here, right? So P and vector V as well. So it might be here, it might be there. Okay, so let's do reverse. So T equal to x minus 3 over 4 and T equal to y plus 1 over 2. T equal to z minus 3. Now let us solve for x, solve for y, solve for z, right? Okay, then x equal to 3 plus 4t and y equal to negative 1 plus 2t and z equal to 3 plus t. All right. Then we have a form, parametric equation that is x equal to x naught plus at, y equal to y naught plus bt, z equal to z naught plus ct, right? Then vector v, we call this is direction vector. So direction vector for p q, but there is no pq yet. Okay, direction, just call the direction vector for now. Okay, then v equal to abc, right? abc. Okay, in that case, we have, that will be abc, right? A, B, C. Yeah. So that is 4, 2, positive 1, right? Okay. That is a vector V. Now, we want to find the vector PM. All right, then we have to have one more order pair. I mean, not order pair, the triple pair, right? Because we have a point, right? Okay. Then this will be a point because the form is x naught, y naught, z naught, right? So let's denote this way. P as x naught, y naught, z naught equal to, we have 3, -1, +3, right? All right, so we have m equal to m equal to 1, 1, 3, right? Okay, we can find the vector. So Pm equal to vector component form, which is the terminal is m. So 1 minus 3, 1 minus minus 1, 3 minus 3, right? So that will be -2 to 0. Okay. Now, we want to find the distance. That is the goal, right? Then we have to have the cross product of vector Pm with vector V, right? So Pm cross product of vector V, which is I, J, K. Then Pm, which is -2 to 0, V, which is 4 to 1, right? All right, so that will be I minus J plus K, right? Plus, minus, plus. Okay, I. We have 2021. J, we have -2041. And K, we have -2242. That will be multiply. So we have 2 minus 0, I had, and -2 minus 0, J hat, and -4 minus 8, K hat. So that would be 2 I hat plus 2 J hat minus 12 K hat. Now take the magnitude of that. Equal to 2 squared plus 2 squared plus -12 squared. So that will be 100 square root of 152. Thank you. Okay. What about the magnitude of vector V? So let's just do that. D equal to copy. Paste. So we have a square root of 152 over magnitude of vector V. So I am using this number, 421. Can you please calculate? Which is square root of 21. So approximately is 2.69 units, right? Okay. I think I saw the answer earlier in the picture. So right here. They say that this point, say M, is approximately 2.7 units, yeah? So 2.69, approximately 2.7 units with the distance, with the line. Make sense? Very good. Okay, so we have a relationship between lines here. Okay, so in 2 dimension, we had a parallel or perpendicular or intersect, right? So we have a two in 2D parallel. Two lines are parallel, right? Or intersecting point, right? But then in 3 dimension, we have this line, two lines. Looks like in 2 dimension. Think about in 2 dimension. If the line keep continue, then they intersect eventually, right? But in 3 dimension, they never met. Can you see that? When you image this line, so we call these lines are skew line. This is a skew line. So skew line is neither neither parallel nor intersect line. Intersect line. All right. Okay, let's talk about this one. Lines share. So this is the question. Lines shares a common point. So we have a yes. We have a no here. And doesn't look, and this is also, let me draw. And here, this side question, direction vectors. So we had the direction vectors, vector v, a, b, c, from the parametric equation, right? So a, b, c vectors are parallel. So in that case, we have yes, no, there's no, yeah. So basically, line shares a common point, yes. And direction vectors are parallel, yes. Then look, line one, this line one, let's denote L sub one. And then line two, L sub two. So they are equal each other. So equal, identical, right? Okay, how about this? Lines shares common point? No. And direction vectors are parallel? Yes, yes, right? In that case, we have a line one. Ooh, one. And we have a line two, right? No common parts, but they are parallel each other, right? So we call this as a parallel. How about third one? The lines shares common part? Yes. Direction vectors are parallel? No. In that case, we have line 1 and then line 2, right? So we call this is intersect. How about the last one? Lines shares common part? No. Direction vectors are parallel? No. We just learned that skew line, right? So line 1 and line 2. Skew. Okay, let me bring the example here. Okay, so here is a example. Determine whether the lines are equal, parallel, but not equal, skew, or intersecting. So we have a line 1, x equal to negative y equal to z, and line 2, x minus 3 over 2 equal to y equal to z minus 2. So both are symmetric equation, right? All right, so from note the line 1, right, we can see that t equal to x and t equal to negative y, t equal to z, right? Then if we make a divide by negative 1, the second one, then we have y equal to negative t. What about the line 2, right? So we have x minus 3 over 2. We set up this is t equal to, then solve for t. Sorry, solve for x, not the t. Then we have x equal to 2t plus 3. Second one, t equal to y, right? And third one, t equal to z minus 2. Solve for z. Then we get z equal to 2, sorry, t plus 2, right? Okay, so let's make a direction vector from the line 1. So v sub 1, we denote this way, direction vector. So we will have the ABC, right? So ABC come from x equal to x naught plus AT, y equal to y naught plus BT, z equal to z naught plus CT, right? Those ABC. Okay, then in that case, we have one, right? And then second one B, which is negative one. It's a 1, negative, excuse me, -1. And this is also 1, right? So 1, -1, 1. How about second vector? So let's take a look. We have, oh, the order is different, right? So, but then that vector 2, and then this is 1, 2, 1, 1, right? V sub 2 will be 2, 1, 1. Okay, so what do you think about two vectors, two lines? Yeah. So we have 1, -1, 1. V sub 2, which is 2, 1, 1. We cannot see there is like a double or 1/2, 1/3, like that, right? Or triple each other, right? So we said no parallel. What if they were parallel? So we might think about the scalar, right? So what if they were parallel? Then if we have u equal to 1, -1, oh, copy wrong. Positive 1 there, right? So this is a positive 1. Let me using same notation. V sub 1 equal to 1, -1, 1. Then V sub 2 will be 2, -2, 2. Because we can say that V sub 2 equal to 2 times of vector V sub 1, right? Or we can think about others, yeah? So if we have V sub 2 equal to 2, 1, 1, then we might think about V sub 2 as 1/2. Then there will be 1, 1/2, 1/2. Yeah. There will be, let's say that, just say W, right? Different V sub 2, maybe W. This is W2, another W. Okay. All right, let's just show that there are intersecting or not. Show whether they are intersecting. Okay, so we have x equal to t, x equal to t, y equal to -t, z equal to t, and we have x equal to 2t plus 3, y equal to t, and z equal to t plus 2, right? So we have a line 1, line 2, they're using t. So let me using s instead of t for the second line, all right? So Let's do it. Let x equal to t, y equal to negative t, z equal to t. And then we have x equal to 2s plus 3, y equal to s, and z equal to s plus 2. Okay, now we will say that t equal to 2s plus 3 because they say that x equal to t, right? Can I see? Can you see that? We have x equal to 2s plus 3 and then x equal to t. So t equal to that. Yeah. All right. So we have y equal to negative t. So I want to put y. So substitute the negative t into the y, right? So here we go. Negative t equal to s and t equal to s plus 2, right? Okay, let's substitute. Let's substitute 2s plus into the t. Okay? All right. So then negative, we have negative and two different color. 2, 2s plus 3 equal to s. All right. Then let's distribute. So we have negative 2s minus 3 equal to s. Now solve for s. Then we get negative 2s minus s equal to positive 3, right? Okay, then negative 3s equal to 3, s equal to negative 1. All right, let's do it. So s equal to negative 1, let's substitute this one into here. Then we will get t equal to negative 1 plus 2. Then we have t equal to 1, right? So we found s equal to negative 1 and t equal to 1. So substitute. Let's do substitute. Substitute. Into equation number 1. Well, what's the equation number 1? So let's make equation number 1, this one. Equation number 2. Equation number 3. Substitute. By s equal to negative 1 and t equal to positive 1. All right? Okay. So we have equation number 1, which is t equal to 2s plus 3. Okay, so let's check that. Is it 1 equal to 2s which is -1 plus 3. Is it true? Yes. Good job. 1 equal to 1, right? So 1 equal to 1. So it's a true statement. Okay, so we can say that we have this equation. So we have n t equal to 1, right? T equal to 1. Well, we can use this one too. It's up to you. So we can notice that x equal to 1, y equal to -1, z equal to also 1, right? So we can conclude. Therefore, line 1 and line 2 are intersecting. Point at x, y, z, which is equal to, this is so slow, huh? I have to wait. 1, -1, right? Very good. Okay, so here is the picture of intersecting point. So let's denote, this is a point. 1, -1, 1. Okay, so here is a picture. Let's take a look. This is vector PQ from the point, right? And then we have another vector, which is orthogonal, right? Because there is a perpendicular notation. So we called this is a normal vector. Normal vector, which is orthogonal, means orthogonal, perpendicular, right? Means they're perpendicular. Okay. What we learned before, the two vectors are orthogonal, then their dot product equal to 0, right? So can you see that? We have a vector dot product with another vector equal to 0, right? Okay, so then we can just denote vector n indicate with a vector component ABC. So let me write down. So vector n dot product with PQ equal to 0, right? So let's denote vector n equal to ABC with a vector component and dot product with PQ. PQ is, we can denote this way, x minus x naught, y minus y naught, z minus z naught equal to 0, right? Okay, now we can express this one as first component with the first component we multiply, right? So that is ax minus x naught plus b y minus y naught plus CZ minus Z naught equal to 0, right? That's how we get the scalar equation of plane. Can you see that? There is the equation, right? Okay, now we can distribute. So if we distribute, we have AX, oh, not this one, AX minus AX naught plus BY minus BY naught plus CZ minus CZ naught equal to 0. So we call this is a scalar equation, or we say the standard equation, right? Okay, now let's arrange x, y, z left, and then x naught, y naught, z naught right. Okay, that will be ax plus by plus cz and minus this, that. So negative ax naught minus by naught minus cz naught equal to 0. Let's say that this is equal to d, just any variable, right? There's no meaning. So let's say equal to d. Yeah. Then we can express ax plus by plus cz plus d equal to 0. We cannot see. So this is a general equation. So here we go. This is the one. They talk about the general equation of the plane, right? Okay, let's do example. Okay, so here is the question, right? Equation for the plane containing point. So P, Q, R. We want to write down standard and general equation. So standard. So standard, we need to start this one, right? So this is a standard. Standard. So start here. And then the general, right? So, okay, if we distribute and arrange the numbers, combining like term, then we get the general equation, right? Okay, so in order to find ABC in the case of molar vector, and then I denote x naught, y naught, z naught there. So first one, okay? All right. We have to understand this concept. We knew from the cross product. So cross product of two vectors is orthogonal to those vectors respectively, right? So we want to find the cross product. So in order to find the cross product of two vectors, we need to find the vector first, right? So let's find the vector of PQ from the 2 point and then QR. All right, so let's do it. So vector PQ, then 0 minus 1, 2 minus 1, 1 minus minus 2. Then we get negative 1, 1, 3. How about QR? Then R, negative 1, 2, minus 0, negative 1, 2. And 0 minus 1. That would be negative 1, negative 3, negative 1. Okay, so let me write down what I said earlier. So note PQ cross product with QR is orthogonal to PQ and QR, right? So orthogonal means the normal vector, right? Okay, so basically we need to find normal vector to PQ and QR, right? So PQ cross product with QR, which is I, J, K. So we just found negative 1, 1, 3, negative 1, negative 3, negative 1. So that will be I minus J plus K. So I, we have 1, 3, negative 3, negative 1. J, we have negative 1, 3, negative 1, negative 1. K, we have negative 1, 1, negative 1, negative. Yeah. Okay. So let's calculate. This negative 1 minus plus 9, right? I minus and positive 1 negative plus 3 J and plus and positive 3 minus plus 1 K. That will be 8I minus 4J plus 4K. Look, this is normal vector, right? So that would be N, which is we can express vector component to form, which is A negative 4, 4, right? Okay, that will be ABC, right? So we have too many ABC. So earlier we had ABC as a direction vector, right? And then here, normal vector. Okay, so we have X naught, Y naught, Z naught. That we have and we have ABC. And we can just apply, right? Substitute. Okay. paste. Okay. So that will be 8x minus 1 plus -4, y minus 1 plus 4z minus 2. Yeah. We distribute 8x minus 8 minus 4y plus 4 plus 4z plus 8 equal to 0. Combining like terms, so 8x minus 4y plus 4z. I'm done, right? So 0, right? So we have 4 equal to 0. Okay, so this is the equation of the plane who has the point, 3 points, like a PQR, right? Okay, let me show you in the Desmos 3D, 3 dimension here. So I plot the point 1, 1, -2, that's the P, I think. Then Q, then R. So blue, green, red there. Can you see that? And then the equation I typed there, so looks like this. Yeah, that is the equation. 8x minus 4y plus 4z plus 4 equal to 0. Yeah. So let me make just a screenshot for this one. And then arrange there. Oh, you guys okay with it? This? Oh, no. Like that. Okay, so here is the screenshot. And let's do one more problem. Okay, so here is the question. Find the equation of the plane that passes through the point and contains a line, given the symmetric equation, right? So same concept, but we need to have a more step for the find the vectors, right? So it's like this. We want to find the normal vector through the cross product, right? So that is the same concept as earlier. Then after find the normal vector, we just substitute. So that will be x naught, y naught, z naught, right? Done, right? Okay, then this is a symmetric equation. Then t equal to x, t equal to y minus 1 over 2. I need to wait. And t equal to z plus 1. Yeah. Now, if we convert to the parametric equation, we can find one more point and the direction vector, right? Okay, let's do it. Parametric equation. So t equal to x. So x equal to t. Then y equal to 2t plus 1. Solve for x, solve for y, solve for z. Z equal to t minus 1. Yeah. So we have a form x equal to x naught plus at, y equal to y naught plus bt, and z equal to z naught plus ct. So a, b, c is the vector. In that case, it's a direction vector, right? Okay, so what is this? That will be one-to-one. So vector b equal to 1, 2, 1. Okay, how about the point? X naught, y naught, z naught, right? So point Q will be, oh, don't get confused with the earlier X naught, Y naught, Z naught, right? So I just label. So maybe we can say the X, oh, cannot see. If we get confused, we can say the X sub 1, Y sub 1, Z sub 1. Just a label. So don't get confused about that. So X sub 1, Y sub 1, Z sub 1, right? So X sub 1, Y sub 1, Z sub 1, which is equal to, that is a 0, right? And Y sub 1, which is 1, Z sub 1, which is negative 1. Okay. Now, we have a vector, and then we have 2 points. So we can find another vector to find out the cross product of 2 vectors, right? Which is normal vector. So let's do it. PQ, there will be 0 minus 1, 1 minus 4, negative 1 minus 3, which is, I'm waiting for the writing out, everything. Negative 1, negative 3, negative 4. Okay, let's find the normal vector, which is V cross PQ. So that will be I, J, K. V is 1, 2, 1, negative 1, negative 3, negative 4. That will be I minus J plus K. So I, 2, 1, negative 3, negative 4. J, 1, 1, negative 1, negative 4. K, 1, 2, negative 1, negative 3. Yeah. Okay, so let's calculate. There will be negative a minus plus 3I minus negative 4 plus 1j plus, sorry, this is slow, right? And negative 3 plus 2k. All right, so there will be negative 5I minus so positive 3j minus 1k. So that will be normal vector, which is same as -5, 3, -1. No vector. That is ABC. Yeah. Yeah. Just notation. We can use different letter. D, E, E, D, D, A, B, C, D, E, F, D, E, F. Yeah. Does not matter, right? Okay, so we have X naught, Y naught, Z naught. Copy. Paste. And then we have we have normal vector. Then we can write down standard and the general equation of the plane, right? So where's the equation? No, I have to write down? No, here we go. So start with this. Copy. Oh, let me write down. Yeah. So standard equation, general equation, right? Okay. So let's do it. All right. So we have -5x minus 1 and plus 3y minus 3 plus c equal to 3. Sorry, c equal to -1. -1. And z minus z not equal to 3, right? I screw up here, right? So y naught is 4. I was using b, huh? So let me double check. -5x minus 1, 3, y minus 4, negative z minus 3. Yeah? Okay, this is a standard equation. And let's distribute. So we have a -5x plus 5 plus 3y minus 12 minus z plus 3 equal to 0. Please correct me if I make a mistake. Okay, then there will be -5x plus 3y minus z. Combine like term. That's -7, -4 then. Yeah. This general form. Okay, everything okay? All right, how about the graph? Let's take a look. Check it out. The graph. Okay, so here we go. So I put the 1 point, P, 1, 4, 3, and then symmetric equation, which is a line. Can you see that? That's the purple one is the line, right? So that's the line. And then the equation I put in there. Yeah, that's the plane. Equation of the equation for the plane. Who has 1, 4, 3, the point with the line. Yeah. Isn't it cool, right? So it's moving around. So let me just stop and then make a share, not share screen, screenshot. So we have a write down method, right? So let me make this way. Yeah. Oh, this is better. Okay. Come on. Hold on. So here is a screenshot of the picture. Okay, so let's do theorem 2.13, the distance between plane and a point. Okay, so we have a theorem 2.13, the distance between plane and a point. So we had a formula earlier, distance between a line and a point, right? But here, plane and a point. Okay, so basically we have, this is vector QP, and then we project onto vector N. Yeah. Okay, then we just using magnitude of projection QP onto N. Just using formula, just apply. That's it. Okay. All right. So let's do example so we understand this one. Okay, so here is an example. Find the distance between point and the plane given by x minus 2y plus 2z equal to 5. So this point is not from that plane, right? And then we just learned that how to find the equation, right? So this is general form. General, not general, general, right? General equation. Okay, then we knew that this is from a x minus x naught plus b y minus y naught plus c z minus z naught equal to 0, right? So if we multiply b a c, right? Then that coefficient from x y z will be abc, right? So we learned that ABC is normal vector. So we denote the first letter N. Okay, then we are using we are using formula for the magnitude of projection of a vector QP onto N, right? So I just explained to you, right? But then we just follow exactly the formula from what we did earlier, the previous chapter sections, right? So that's the formula. So do you want me to show you this one? So we have a projection. Projection of vector v onto u, right? And we had projection. We had vector u dot product with the vector v over magnitude of vector u, right? So we had absolute value. Okay, now or I am trying to do in that case. So yeah, coefficient of x, y, z will be in that case 1, -2, and +2, right? That's the ABC, which is normal vector. Okay. Let me just copy and paste for, come on. Oh, I cannot make a paste, copy this one. Copy. So let's find out the distance. Oh, okay, never mind. Distance formula, we had absolute value of n dot product with QP over magnitude of n, right? All right. We have n. Now we need to find another point to Q, right? So how do we find the Q? Finding Q. Let's find X. Let's set y equal to 0 and z equal to 0. Then we have equation. This one, general equation. Copy. Then x minus 0 plus 0 equal to 5. Then x equal to 5, right? Then q will be, oh my gosh, you cannot see. Then q will be 5, 0, 0. We can set it up anything, right? Okay, now QP, we want to find the vectors. So 5, P equal to 3, 1, 2. Talk too much, huh? Hold on 1 second. We have so 5 minus 3, 0 minus 1, 0 minus 2. That will be 2, -1, -2. Okay, let's bring up the formula here again. Copy. So that will be absolute value of dot product. I need to see n. And where's n? Hi. 1, 2, 2. 1, 1, -2, 2. Copy. All right. Dot product, dot product, 1, -2, 2. Dot with a P, QP. So 2, -1, -2. All over square root of n And n is 1 squared plus negative 2 squared plus 2 squared. Yeah. That's the n, right? Did I make a mistake? Hold on 1 second. N is something weird. I copied wrong. Sorry about that. I copied wrong. So it should be Z instead of 2Z. Sorry about that. Yeah. Then there will be 1. And there will be 1. That's it. Yeah. So there will be 1. And there will be 1. Yeah. Just a mistake there. That's it. Okay. Then what do we have? So we get 4, 5, 6. Denominator has a 6. Square root of 6. And numerator has 1 times 2 times plus negative 2 times negative 1 plus 1 times negative 2. Absolute value. 2, negative 2. It's negative 2, right? So it's absolute value equal to 2 over square root of 6. Yeah, that's the distance. You might calculate approximation. Okay, so I have this one. Let me read. When two planes are parallel, we're not talking about the line. We had a line earlier, right? Two lines are parallel, two lines are intersect, neither parallel nor intersect, then skew line, right? So we are talking about the planes. Yeah, this is a plane. This is a plane. So two planes are parallel. Their normal vectors are parallel. Normal vectors means the orthogonal perpendicular, right? When two planes intersect, this is intersect. The intersection is the line. This is a line, okay? Okay, so we have an example. Find the parametric and symmetric equation for the line formed by the intersection of the planes given by two equations. Yeah. So they are plane, and we want to find the equation of the line, right? So line, the form is parametric or symmetric, right? Okay, so symmetric, we had the form. I'm sorry, parametric. Parametric. We have x equal to x naught plus at, y equal to y naught plus bt, z equal to z naught plus ct. I have to wait. All right. Still not come up. Okay, come up, right? Okay. Then symmetric equation we need to solve for t, right? So symmetric equation solve for t from the parametric okay. So let's do it. So we have a equation of planes, two planes, right? Two equations from the two planes. So let's say the equation number one, we have x plus y plus z equal to 0. And equation number two, we have 2x minus y plus z equal to 0, right? So system of equations we have, oh, not yet. Oh, almost done, hanging there. So we can simplify y easily. So we have 3x plus 2z equal to 0. Then let's solve for x. So x equal to, that's the 2z over 3 then, negative, yeah? 2z over 3. Okay, let's substitute into equation number one. Substitute into equation number one. So x plus y plus z equal to 0. So x will be negative 2z over 3. Yeah. Plus y plus z equal to 0. 네, we get, we get we can combine like term, z term, and then we can solve for y, right? So solve for y. Then we have, this is 3 over 3, z. Then there's 1 over 3. There will be negative 1 over 3 z then, right? So y equal to negative 1 over 3 is z. Make sense? Okay, now let's let y equal to t. Then t equal to negative 1/3 of z. Yeah. Then let's solve for z. Yeah. And solve for z. There will be times negative 3. So z equal to negative 3t then. Okay. Then we have from here x equal to x equal to negative 2z over 3. We have x equal to negative 2z over 3. Let's substitute. Which color is good? Then we will have equal to negative 2/3 and negative 3t. Simplify. Then we get positive 2t then. Right? Okay. x equal to 2t, then x equal to 2t, we say the y equal to t and z equal to negative 3t, right? So we found the parametric equation. So parametric equation. So x equal to 2t, y equal to t, z equal to negative 3t. And then solve for t. Then t equal to x over 2. Oh, just itself. Y equal to t. And t equal to z over negative z over 3, right? Negative z over 3. Okay, so everything together, symmetric equation will be x over 2 equal to t, no, y, y equal to negative z over 3. This is a symmetric equation. Yeah. Any question? Okay, last problem here. Okay. Let me bring the questions here. Okay, so we have the question determine whether each pair of planes is parallel, orthogonal, or neither. So how they find? So previously, when you find the angle, let me write down. Note previously for finding angle. So we are using cosine theta equal to dot product of u and v over magnitude of u and magnitude of v. Okay, now this section, I want to add one more. The vector, two vectors are orthogonal vectors. Then we have just absolute value of numerator, and then same as the denominator as this formula. Okay, so let me write down. If vector n sub 1 and n sub 2 are orthogonal vectors, means they're perpendicular, right? So perpendicular. Then we have cosine theta equal to absolute value of the product of two vectors over and then same formula follow. So magnitude of n sub 1 and magnitude of n sub 2. All right? Okay. The first one. So we have x plus 2y minus z equal to 8 and 2x plus 4y minus 2z equal to 10. Okay, so we had the experience earlier. So what is a normal vector? We are using only the coefficient of x, y, z, right? So that is a normal vector. So 1, 2, negative 1. Yeah. So normal vector n sub 1, 1, 2, negative 1. Why this one? Okay, second one, we have 2, 4, negative 2, right? What? And sub 2 equal to 2, 4, negative 2. Okay, let's check the parallel. Can you please think? This vector, the first vector is scalar of second vector, or second vector is a scalar with the first vector, right? N sub 2 equal to 2, n sub 1. Very good. Thank you. So yes, it's a parallel, right? So let me write down. So we have a 2, 4, negative 2 equal to 2 times of what? 1, 2, negative 1, right? Okay. How about second one? So last one, this one, 2x minus a 3y plus 2z equal to 3. And 6x plus 2y minus 3z equal to 1. Okay. The normal vector we had the coefficient of so first one, which is 2, negative 3, 2. And second one, 6, positive 2, negative 3, right? 6, 2, negative 3. Okay, let's check the parallel like earlier. Let me just copy. Ah, last problem hanging there. I know, so tired, right? I cannot. Come on, let's do it. Copy. Yeah, iPad is so slow today. Okay, so you think, what do you think? You cannot think about that? Okay, then let's say that no parallel, right? All right, then let's check the orthogonal. How do we check the orthogonal? Show that it's orthogonal. So we can show that dot product of two vectors equal to 0, right? I'm waiting. Okay, show 1, 2. Okay, so let's show that. Otherwise, we have to find the angle, right? By using the cosine theta earlier, right? So we answer, yeah, just writing. Answer 2 equal to 2, negative 3, 2. Dot product with 6, 2, negative 3. There will be 6 times 6, 6 times 6, 2 times 6, And negative 3 times 2 plus 2 times negative 3. Can you please calculate? 0. Good job. Thank you very much. So we don't have to find the angle theta then, right? So if this is now orthogonal, we are using cosine theta, earlier the formula, to find out the angle, right? So this is 0, so it's orthogonal. The planes are orthogonal. Okay, we are done for this section. Yeah, always long section. Thank you very much for watching. I will see you in 2.6. Bye.